with that continuous deformation from the around hug, pulling it over and having your normal front viewing knot slash hug, they're not obviously the same hug or obviously the same thing. And that's one of the real difficulties in knot theory. Is this knot the same as another knot? So something you can look at is colouring knots. I'm pretty sure you've got plenty of videos on colouring knots. But you look for an invariance, something that doesn't change. So in the physical world, if you're hugging, it's great because you can untangle it, you can retangle it. You're like, this is the same knot no matter what I do, because nobody's unheld hands, it is the same knot. But if you're looking at these, this knot here is not necessarily the same as, I'll draw another one here, which is the same knot, but you might not recognize it as the same. Okay, let me just check my over-unders. Over, under, over, under. Ooh, under, under. Well, here's how I can tell if it's the same knot, but from a different view. We can three-color it. So colouring a knot is an invariance. So if you can do the same thing here and the same thing here, then they are the same knot. So like on this knot here, I could make this a kind of green and blue section. And I could do that for, say, this bit here. Green and blue. I can make this one a pinky section. And let's go with this one being a pinky section. And then you've got just your normal blue section. So this is three-colorable, this is three-colorable. They're the same knot. They've got an invariance. They look like different knots, and they would look like different hugs. They are the same knot. I have tried, this is gonna make me sound like such a sad person. I've tried to do these hug knots on my own. It doesn't work.
What do you even do?
Well, so this trefoil knot, the 3-1 knot, is sometimes called the overhand knot, like as if you were to tie an overhand shoelace, or just like fold your arms. That's the start of an overhand knot. So if I could fold my arms like this and like somehow get my hands to reach together, I know I can't do it. That's why mathematicians need friends. But yeah, so that, if my hands could reach together, would be the same knot. With the chirality as well, the opposite way of folding your arms, again, if I could reach my hands together, would be the same knot. But you need friends for this kind of maths. You need...
Just fold your arms like that again. So what hand would have to go where? This hand?
This hand would have to come around
through there?
Yeah,
up
to this hand here. Yeah. And then doing it the other way around is also horrible. Yeah, and then I also, for a while, thought that I might be able to do a kind of knot, but it's not. It turns out just to be the same as the unknot. You see my weird trick. So, if you do this, let me see if I can do this without ruining my hair. So I hope this isn't the weirdest thing that's happened on a NUMBERPHILE video.
It's in the top 10.
So this, I thought, might be a knot that I could do myself. It's not a knot, because what you're doing there is called a Riedmeister move. So if I take from this, it looks like there might be a loop or a knot or something, but you can actually, it is just the unknot, unfortunately. So you do need buddies to do this. Other than getting wonderful hugs from my mum, why would I spend my time like trying to figure out weird knot things? And both parts there, knots and chirality, really interesting developing parts of maths that are going on right now. So for example, the chirality issue, that's applicable in chemistry, physics, biology, all of the sciences, but you want to bring it down into the real world. Like as you've seen, there are things which in maths world are possible, because we tend to think of strings or ribbons as having zero width, so anything can happen. But could that actually work in the real world? Can you give yourself a trefoil hug in the real world? No. Someone had to try it. It doesn't work, I know that now. But with chemistry, you can get two different chemical molecules, which are the exact same molecules, but have a chirality, a left-handed and a right-handedness, and they smell totally different. You can get one that smells of lemon and orange, same molecule, different smells. Or in an even more serious situation, you can have medicines which work well, but their chiral molecule could be either completely ineffective or very harmful. So that kind of serious chirality consideration is what led to the thalidomide disaster, and they had two different isomers of the same molecule, same medicine, but one was left-handed, one was right-handed. They thought, we'll cover both bases, put them both in, but it turns out that one of them does have disastrous effects, unfortunately, and the other one would work very well as a medicine, but we kind of avoid that now. Chirality and, I mean, knots, I think you've got videos as well about knots being used in DNA. There's all kinds of long-chain polymer molecules. These are things which happen in the real world. It's all hugs and fun in maths world, but is it going to work for our scientists? And I think when it comes to current developments, everything that comes from here on in is going to be as a result of interdisciplinary learning, people working together with mathematicians, biology, chemistry, physics, science. There's some amazing things going on with maths and anatomy or biology right now. So if you think you are not a maths person, like my mum did, you probably are. You just need to look at it in the right way. And if you are a maths person, you need to find someone who's not a maths person and give them a hug, get them involved in the maths world, because all of the amazing things that are to come from here on in are going to be collaborations with maths and everyone else. And then you're into the trefoil hug. I made it for you.
Oh, thank you.
But you'd rather just a normal hug.
You'd rather not.
It's moving piecewise, but just slower than this top one. And it goes from the other direction. All of the purple pieces, as I solve it, they're moving in a little cycle. They're going A, B, C, A, B, C.